Modify distribution. First, in the question given, first solve and find the total cost using Northwest method or VAM. After we find the total cost, find the optimal solution, use the MODI method. Next, check the degeneracy, where m plus n minus 1 is checked. M is number of rows, n is number of columns. Rows is A, B and C. Columns is P, Q and R. So it is 3 plus 3 minus 1 is equal to 5. Number of cells allocated is also 5, which means there is no degeneracy. The number of allocated cells means the cells which are allocated here, which is 5, 7, 4, 7 and 7. After we find that there is no degeneracy, we solve to find the optimal solution. Allocate A, B, C as U1, U2 and U3, P, Q, R as V1, V2 and V3. Write down the C11, which is 5. Here this C, I, J. This is row and this is column. I is row, J is column. So for C11 it is first row and first column. For C12 it is first row and second column, which is 7. Similarly, do for all the elements in the table. We will get all the values. Find the unallocated cells. Here the unallocated cells are 8, 4, 6 and 6. Write down the unallocated cells. Next, find the maximum number of allocations. In row A and row C, there are 2 allocations, 1 and 2, 1 and 2. Also in column P and column Q, there are 2 allocations. We have to select any one row or column. Max number of allocations are there in row A and row C and column PQ. So select any one. We have selected row A. When we select row A, the whole U1 becomes 0. So now let's consider only allocated cells, where U1 plus V1 is equal to 5, which means U1 plus V1 is equal to 5. Like U1 and V2 is equal to 7. U1 and V3 is equal to 8. Like that, do for only allocated cells. U2 and V1 is 4. U3 and V2 is 7. U3 and V3 is also 7. Solve the equations. U1 is equal to 0. U1 plus V1 is equal to 5. 0 plus V1 is equal to 5. V1 is equal to 5. U1 plus V2 is equal to 7. This is 0. So V2 is equal to 7. U2 plus V1 is equal to 4. We got V1 is equal to 5. So substitute here. U2 plus 5 is equal to U2 plus 5 is equal to 4, which gives U2 is equal to 4 minus 5 is equal to minus 1. U2 is equal to minus 1. U3 plus V2 is equal to 7. V2 is 7. So U3 plus 7 is equal to 7. U3 is equal to 0. Next, U3 plus V3 is equal to 7. U3 is 0. Hence, V3 is equal to 7. For the unallocated cells, this is the formula, where x13 means this is I and this is j. X13 we have 8 minus U1 minus V3. It is 8 minus U1 we got 0 minus V3 we got 7. 8 minus 7 is 1. Next, for unallocated, X22 is unallocated. So X22 we got 4 minus U2 minus V2 is equal to 4 minus of minus 1. U2 we got minus 1 minus V2 we got 7 is equal to minus 2. X31 is equal to X31 we got 6 minus U3 minus V1 is equal to 6 minus 0 minus 5 is equal to 1. X33 is equal to 7 minus 0 minus 7 is equal to 0. In these values, we got one negative value, which is minus 2. If there were all positive elements, the optimal solution would have been reached. As there is a negative value, we have to further calculate the steps. Select the highest negative value. Draw a closed loop from selected cell in such a way that corners of loop is allocated. We got minus 2 as negative, which is x22. So in the table, x22 falls here, which is second row and second column. So this is x22. So based on this, form a closed loop. A closed loop is formed where the corners should be allocated. Hence, when we draw a loop here, the corners, which is 4, 5 and 7, all three are allocated. Hence, this is the closed loop. Example, if we use this as a closed loop, this is not allocated. Also, if we use these two are not allocated. Hence, this is the option here. Every adjacent corner is given opposite sign. In this closed loop, if this is given positive sign, the opposite should be negative. If this is negative, this should be positive, and again this should be negative. So the every adjacent corner is given opposite sign. So AP becomes positive, AQ becomes negative, BP becomes negative, BQ becomes positive. So in this table, AP becomes positive, this will be negative, this will be positive, this will be negative. Select the negative signs and choose the least allocated. Here the least allocated is 30. Now 30 is added to the positive and subtracted to negative. So 35 plus 30 is 65, 35 minus 30 is 5, 30 minus 30 is 0, 0 plus 30 is 30. This will be our final table. Based on this, the total cost is calculated like 5 into 65, 7 into 5, 4 into 30, 7 into 7 and 7 into 43. Write down all the values of the element. C11 is 5, which means the first row and first column. First row and first column is 5. C12 is 7, which means first row and second column is 7. Similarly, do for all the elements. Now check the unallocated cells. Here unallocated are x13, x21, x23, x31. So these cells are unallocated 8, 4, 6 and 6. Check the maximum allocated row or column, which is in this it is V2, which is maximum allocated. Hence V2 becomes 0. Write down the equations for allocated cells. U1 plus V1 is equal to 5, which means this is U1, this is V1. So U1 plus V1 is 5, U1 plus V2 is 7, U2 plus V2 is 4, U3 plus V2 is 7, U3 plus V3 is 7. All these equations. V2 is equal to 0. Hence start from where there are already V2. So if this is 0 and this is 0, like V2 is 0, so automatically U1 is equal to 7 and U2 will be 4. Next, solve this. U1 is already given, so V1 is equal to 5 minus 7, which gives minus 2. Next, U3 plus V2 is 7, V2 is 0, so U3 is equal to 7. Thus, U3 plus V3 as U3 is 7 plus V3 is equal to 7, so V3 will be 0. Next, calculated the unallocated cells. This is the formula. C13 minus U1 minus V3. C13 is 8 minus U1. We got U1 as 7 minus V3 is 0, which gives 1. Next, C21, which is 4 minus U2 is 4 minus V1 is minus 2, which gives 2. Next, 6 minus 4 minus 0, which is 2. Next is 6 minus 7 minus of minus 2, which gives minus 1 plus 2 is equal to 1. All the numbers are positive. Hence, optimal solution.